second day of KVM Forum. My name is Borntraeger. I work for IBM Z, or as you probably know, as S390. And I'm giving today the KVM status report, the keynote for KVM. Also some nice greetings from IBM Legal. So what is the state of IBM of KVM today? We have 6 architectures mostly, or you could count them differently, combining ARM, or actually say that Power is 2 architectures, but let's say roughly 6 architectures that are in tree and all maintained. We have ARM, we have MIPS, we have Power, we have x86 and the S390 platform. And in fact, one new architecture is on the horizon, and you have probably seen yesterday's talk by Alistair and Anoop. And I think it's a good sign to actually have a growing number of architectures in a project, because it shows how active that project still is. We have 2 core maintainers for KVM, Paolo and Radim, and all architectures are maintained, as I said. Unfortunately, on the ARM side, Christopher Dow has no longer time to be a full-time maintainer, so he stepped back on that. And while he's still doing review for ARM, I will certainly miss his presentations and his reviews on the list. That was quite good. When you look at KVM, we all know the main usage of KVM to be able to run guests or virtual machines, and to also function as a base for infrastructure as a service, for your data center virtualization, and also new use cases like KubeVirt. And actually, there's more work in progress in the QEMU side to cover even more use cases. I think Paolo will talk a bit about that in his keynote afterwards. But in addition to QEMU libvirt, there's actually a zoo of different other user spaces that use KVM as its base. I mean, we have the native KVM tool, for example. In the Chrome OS, there is the CrossVM. We have from Amazon the Firecracker, which is used for the function as a service. We don't have Rust VMM. By the way, Firecracker and Rust VMM have a talk today and tomorrow, so I think you will probably be able to see that. And there's a lot more different user spaces for KVM. And in fact, when you look at cloud providers like Google, Amazon, Nutanix, Tencent Cloud, IBM, you name it, actually KVM usage in terms of the KVM part of the kernel is not tied to a single user space stack. That brings me to a different point about KVM. KVM is now used as a building block for a huge amount of different use cases that go far beyond the initial scheme of being able to run a virtual machine. KVM is used as a building block for container isolation, with Kata container, for example. The IBM Cloud uses a different tool called RunQ. It's also open source. It's kind of similar to Kata, a bit simpler, but different providers actually use KVM with specific means to do work that was not the original idea. The gvisor from Google also has a KVM backend. And KVM is also used together with QEMU libvirt in other use cases like Kubernetes with KubeVirt. So whenever you need a component that provides a virtual machine, then KVM seems to be the first choice in the market, which is a good sign. And it actually shows also when you look at some statistics. I logged the amount of commits per every release, and going back to 3.8. And then I just asked the LibreOffice to, let's just give the trend line. And you can see that the trend line of the commits is growing over time. Not huge, but we are growing over time, and it's a steady growth. We are still on that track, which is good. Let's also look into some statistics. Again, I did that 2 years ago. Paolo did it last year. So I basically started when Paolo stopped with 420 RC1, and I counted up to 54 RC1. And we have a similar number of commits like the years before, slightly growing, as I said. We have, again, about 10% of the commits are merge commits. And out of these 1,100 commits, 319 have a reviewed by tag. And this is something where we actually regressed. Last year, we had, 2 years ago, we had 417 reviewed buys in our list of patches with a similar amount of commits. Same goes for arc buy. I mean, this year we had 87 arc buys in the commits, and 2 years ago it was 200. So this is something where I probably blame a bit the loss of Christopher Dell, because he was very active in reviewing and hacking patches. But I encourage you to actually, when you have patches, try to get at least one peer review, and if you have one, just note it down in the patch. That would be good. Yeah. Where we have a different number is also the patches that contain a fixes tag. 2 years ago it was 125, now we have 222. Does it mean that we have more bugs, or does it mean that we fix more bugs? I hope it's the latter, but we should also improve ourselves to avoid bugs in the first place, I guess. But that we are actively tracking bugs, adding fixes tags is actually a good thing. Okay, let's also look into what reviewer, or what persons did the majority of the work. I have here a list of top authors. On first place is Sean Christopherson with very impressive 227 patches. Paolo follows on the second place, which is also quite interesting, considering that he is actually a maintainer and he's doing a lot of other work around that. We then have Vitaly Kuznetsov, Marc Strongier, and Dave Martin on the following places. Another important thing is the reviews. And the top reviewers, we have Jim Madsen from Google, Sean Christopherson, Intel, Cornelia Hook, Andrew Jones, and David Hildenbrand on the next places. And last but not least, we have people creating patches with the fixes tag. And on the top list, again, we have Sean Christopherson, then Vitaly, Paolo, Mark, and Paul. So I want to thank to basically all participants in KVM, not only the top list, but I think it's actually a good moment to thank these people for their work in improving KVM. Let's look at the companies. I think we have names similar to the last year, but also some new names growing over time. First place, we have Intel and Red Hat, IBM, but we also have ARM. We then also have with Google, Oracle, Tencent Cloud, Amazon. We now have a lot of cloud providers participating in KVM. And that is also a good sign. And that actually reflects my first statement, that KVM is now used beyond its initial use case of having just provide virtual machines. Okay, so let's look into some highlights so that people will hopefully find themselves on their chart. What did we do in the last year? Overall, KVM started to implement the memory controller accounting. This is now done for the KVM core code, but also on x86. I think this is something where other architectures should follow up and just account the k-mallocs in the kernel to the right memory controller, so that C group can actually limit its use beyond x86. We had improvements in the area of dirty pages tracking, and in the kernel there is now a big effort going on to improve the documentation and changing the classic ASCII text-based file into the RST format, which also allows to have some kind of links and formatting and these kind of things. And we participated in that. I also want to highlight some changes that we have made in the testing area. There are actually two projects pretty closely related to the KVM kernel part. It's first the in-kernel self-tests. They, I think for 2 years now, we have now a self-test backend. And recently we added S390, thanks to Thomas Hood for that. So we have ARM64, S390, and x86 in these self-tests. And same goes for KVM unit tests. So we have ARM, Power, S390, and x86. Would be nice to see more, but the testing is also growing across the architectures, and this is a good thing. Looking at x86, I would see 4 main topics. Nesting is now enabled by default, and it has seen a lot of improvements over there. So, for example, we have a higher accuracy of events. We improved our interaction with Hyper-V by with the enlightened VM control blocks. There's still some more work to do on AMD, but a lot of progress going on, and this is, we have seen that yesterday, also driven by cloud providers like Google, because in the cloud, customers are asking for nesting capabilities because they want to, for example, be able to run kata inside a virtual machine that is provided by the cloud. Then we have more para-virtualization on x86, so we have yield capabilities and other Hyper-V enlightenments. The third area that I see for x86 is SYN virtualization, where we actually try to make the hypervisor overhead thinner, or actually try to give the guest more access to the hardware. So things like exit-less timers, C-state MSRs, and so on. And of course, optimizations and new hardware features. On the ARM side, I grouped all these things into 4 categories. Security, so of course still some kind of follow-up on the big security events that we have seen in the last 2 years. Then of course guest features in ARM, so we now have larger IPA space, we can directly assign timers, have these scalable vector extensions, and many things more. And of course, last but not least, this actually shows also very well-maintained architecture if you invest a lot in hygiene topics, so fixing things, improving small things, and so on. On S390, we had basically 2 big topics. First topic is that we now have the capability of virtualizing crypto adapters. On the platform, we have a real HSM module for crypto operations with secure key, and that can, by the hardware, already be split up into 85 subcards. You could say virtual functions on the PCI, and we can now assign these small subparts to guests and allow guests to talk to the HSM directly. And of course, we had the new machine, the Z15, so we implemented that features. And again, for S390, we also invested in hygiene. On power, I see 4 topics. Again, nested virtualization seems to be quite interesting, and a lot of growing interest was also seen last year and this year again. You can now also assign the XIVE controller, the interrupt controller, to the guest, and that reduces latency and improves performance. That is a new feature of Power 9. A very important feature for Power is certainly the protected execution facility, where you can run a guest without the host being able to see the guest memory and the guest state. Very interesting topic, similar to the AMD SEV solution. Not similar, but has the same intention. And last but not least, optimization. On the MIPS side, things are a little bit slower last years, but you still have seen cleanups and small optimizations. So it's still maintained, and hopefully this will continue to be the case. And last but not least, we have the list of RISC-V patches on the mailing list. And it actually shows that the initial RISC-V port already contains the majority of the important features of KVM. So we are actually looking forward to the stabilization of that architecture, and hopefully next year we can say we have 1 architecture more in 3. That would be good. Time is running out, so last duty I have to do is enjoy the rest of KVM Forum, and please talk to other people. The interaction is certainly what makes this forum the most interesting place to be. Thanks.